All right. So Gary, welcome.
Thanks.
Glad you could pop in.
Nice to be virtually here.
Yes. So yeah, since you've had an interesting trajectory, so you started out as a cognitive psychologist, and now you've wandered into AI. So what was your path to get there?
I was actually interested in AI before I was interested in cognitive science. And I would say I'm more of a cognitive scientist than a cognitive psychologist. And the way I started there was I learned how to program on a paper computer when I was 8 years old, which is basically assembly language, more or less. Um, and very quickly wanted to make a computer that would do things like play games with me. And then I got interested in natural language understanding. I skipped the last 2 years of high school mostly on the basis of a Latin translator that I'd written in Logo on a Commodore 64. And so I had interest in AI back then, but I grew disaffected with AI and got really interested in cognitive psychology and cognitive science more generally. It was like, well, these things that I'm building, they're total hacks. They don't really work. And, maybe I should figure out how people managed to reason about the world. My undergrad was really about reasoning. I became incredibly disheartened about human reasoning for reasons that I think resonate greatly right now when we look at the political situation. I was looking at belief revision and how people revise their priors in light of what they see, and wasn't very pleased with that. But then I shifted to language acquisition in graduate school. I had looked at a bunch of different possible mentors for graduate school, different graduate schools. And I loved what Steve Pinker was doing with the past tense project that he was working on, because it seemed to me that it was getting at foundational questions. How does the human machine actually work? And so I got involved in that project. That led me to neural networks, because the one classical view was that kids were overgeneralizing based on a rule, and the other, more recent at that point idea was maybe they use a neural network instead, and there is no rule. Then I went off and did all kinds of other things. I got very interested in innateness and how that might be represented biologically. Didn't really think about AI for that much. And then I had this moment where a prior that I had was wrong, which was I thought there was no way that an AI system was going to be able to beat humans in natural language understanding. And there it was, Watson had won in Jeopardy. And I was like, how did that happen? Well, it turns out that it was a bit of a cheat, because 95% of the answers are titles of Wikipedia pages. So it was really an exercise in information retrieval rather than natural language understanding and inference and so forth. But it was enough of a cheat that it got me back into the whole thing after an excursion learning to play guitar. We can talk about some other time. And that got me interested in AI, and I started writing about it, thinking about it. And I've basically been hooked ever since for the last 8 or 9 years, thinking about what do I know as a cognitive scientist who is focused on human children and how they learn about the world that might tell us something useful about how we should build our AI. And meanwhile, I've become known as this heretic, because what I think is important are things like knowledge and symbols and stuff like that. Not that I don't think there's any room for neural networks, but I really don't think they're the right answer. And it gets harder and harder for me to make that argument as there's more and more data being piped into these things. But I actually think those arguments are still correct, and that you can add another 2 orders of magnitude and get GPT-4, and it's still not really solving the problems in what I think are the correct and robust ways.
So speaking of that, so I took the Next Decade article and stuck a pointer to that in the Slack channel for this conversation, so that
my archive article, Next Decade.
Yeah,
great.
So people could catch up. So one of the things you said in there was deep learning techniques thus far have proven to be data hungry, shallow, brittle, and limited in their ability to generalize. So what do you really think?
That's pretty much what I think. I mean, and I haven't changed on that. Like, people are always, trying to accuse me of, changing the bar and moving the goalposts and stuff like that. But those are the same things I pointed out, for example, exactly the same things that I pointed out at the beginning of 2018 when I wrote another vaguely heretical article called Deep Learning: A Critical Appraisal. I think most of the things I say in that paper are actually taken now to be received wisdom. But when I put that paper out, Jan LeCun told the world that it was, possibly interesting, but mostly wrong. And I got, millions of people attacking me on Twitter. and so forth. And the main thing that I said there was that it was data hungry, and people kind of now agree with that. And if you think GPT-3 works, you have to acknowledge that it has trillions of data points in order to do what it does. Of course, I don't think that it works as well as I'd like it to. But even if you do think it works, then you have to say, yeah, you need a lot of data. And I said that it's brittle, and it, even GPT-3 with it's probably 4 orders of magnitude more than anybody had in 2018. It's still brittle. The generalization is still dodgy. Sometimes it's really impressive, and sometimes it just like falls flat on its face. And those things haven't really changed. And you go back, rewind to my first publication was an SRCD monograph, Child Development Society monograph, with Steve Pinker in 1992, and we basically said, you construed as a system for producing regular verbs, the neural networks then, which had one hidden layer, not 20, and had small corpus. Basically, what we were saying is they're brittle and you can't count on their generalization. So truth is, I haven't moved the goalposts, or at least haven't moved them much. I'm still talking about the same stuff 30 years later. It's still the core problem that needs to be addressed.
So what would be your bet about when these things work, when they work, why?
Why they work? Well, I have that metaphor in that paper about shadows, and I think that captures it, which is there are a lot of interesting shadows of the world. So fundamentally, what something like GPT is learning, I won't keep saying 2 or 3 or whatever, but GPT, what it's learning is about the statistics of how words are used together. And it's getting more and more sophisticated about that. So it can learn, not just like 2 words previous like you would in a trigram model, but it's learning about 2,000 words previous and all kinds of combinations. But it's not about the world, it's about the world of usage. And there's a critical difference there. And that question is, if that's all you're doing, why do you succeed in anything? Why does it ever work? Like, you get some analogies right. And yet it doesn't have, I would argue, and we can get into that, a real concept of, what a chair is or what a soldier is or, any of the elements that you might pop into your analogies. How does it do that? Well, it turns out the way we talk about things is correlated with the way that they exist in the world. And so if you capture really sophisticated correlations between the words, then you often get things right. And the first taste of that maybe that we got, well, you could argue about the first taste. The first modern taste we got of that was with Word2Vec, which was able to get things like king is to queen as princess to princess or something like that. I forget the exact example. And it did that entirely on word usage. It had no idea what royalty is or age or generation or any of those kinds of things, but it still managed to do pretty well. The catch is sometimes it would just completely blow it, and you couldn't count on it. The subtext of the paper you're mentioning is about robust AI. Like, what would it take to have a system that you can actually trust? As we all know, for example, in driverless cars, there have been driverless cars since 1995 or earlier, 1977. And the problem has always been that they're not robust, that they work some of the time and they crash some of the time. Well, GPT-2 is not going to, 3 is not going to kill anybody. But if you imagine using that as, let's say, your physical reasoning engine, some of the time it works. But if you actually put that in a robot in somebody's home, sooner or later it probably would actually kill somebody, because sometimes it's really, really confused about what's going on, and you can't really count on it.
So part of the problem is that there's the clever Hans phenomena, right? You have something that's the ELIZA effect. You have something that's in language, and so people interpret it the way, if one of us used language, that there would actually be something behind it that was a little richer and was based on
some of that. I call it the rich interpretation problem, which I first noticed not in AI, but with animal language experts. So people would say, well, I spoke to such and such chimpanzee, and I know what it was trying to say was such and such. And, there was no real reason to believe that rich interpretation. I remember going to visit some animals in Eastern Washington that were famous for their signing, and I got there, and there was no actual signing that I could see, and there were videotapes that had been time-stamped from 10 years ago, and they were obviously selectively chosen to illustrate what the experimenter imagined that the animal had in mind. And there's some of that. There was more of that in a way with GPT-2 and 3. Like, GPT-3 authentically comes close to the right answer a reasonable amount of time, and you have to ask, how does it manage to do this? And there's a scientific question, how does it do it? It's just that the answer turns out to be by being completely parasitic on how humans have used words that are related to the concepts that you're feeding in. Like it's beyond just sort of like it randomly once in a while gets something and people are charitable. It really does, get like 60% on something that you might think chance is 2%. You have to engage in that. Why does it, manage the percentage that it does? But the answer is always this parasitic thing, and it's never really that deep. It never really understands the concept. I have some examples here, just so it would be concrete. Like you pour yourself a glass of cranberry, but then absent-mindedly you pour a teaspoon of grape juice into it, okay? You try sniffing it, but you've had a bad cold. You can't smell anything. You're very thirsty, so you drink it. And then GPT-2 or 3 is continuing, so you drink it, which is reasonable. And then it says you're now dead. Well, nobody has ever died, as far as I know, from having a teaspoon of cranberry or a teaspoon of grape juice in their cranberry, right? The system does not understand the biology of how different fluids interact with our body. It can sort of figure out that you drink it because you're thirsty, so there's a correlation between those words. And it's doing that because the correlation between the words, not the concept. It doesn't understand the concept thirsty and the concept drink, and it doesn't understand biology, but that only comes out in the next sentence when it says you're now dead, which is not actually a plausible continuation. And that one example, I think, is very characteristic. Sometimes it does better than that. I mean, I'm almost, well, I don't want to say it that way. I'm selecting an example of where it fails, and sometimes it succeeds. It may even succeed more often than it fails, but this is characteristic of the level of depth, which is it's correlating properties of words like thirsty and drink. Those correlate in the world. When people are thirsty, they tend to have drinks.
Sure.
If you look in a dialogue with it, it doesn't mean it understands these concepts.
So Dan Klein of Semantic Machines remarked recently, well, okay, so if I use a GPT sort of system and my personal assistant schedules the meeting for Friday because that is more likely in the corpus it saw than Thursday, which is what I said, I'm going to be annoyed. Right?
Yeah.
So one of the things, another thing from that paper I thought was an amusing statement was, over the last 3 decades, I've seen a lot of bias against symbols, but I've yet to see a compelling argument against them. Well, okay, so why is there such a bias against symbols?
I don't fully know. I think that it might be secondary to a bias against nativism. And maybe people bristle at the notion that the mind might be a computer of some sort. They just don't want that to be true. Maybe it strips them of their freedom or their individuality or creativity or something like that. I mean, not everybody is biased against symbols. Most professional software developers, live and breathe symbols all the time. And logicians do, and mathematicians. It's not universal, but I've seen it pretty widely. I see, it comes out in the asymmetries people use in kind of burden of proof arguments. Jerry Salmon had the great phrase about burden tennis. And people kind of want people who believe in symbols to prove that there are symbols, whereas people who deny the symbols just get off like, oh yeah, that's brain inspired. And of course, we have no idea, what exactly the brain stuff does when you understand it at an abstract level. And in fact, that you have to acknowledge at least that like logicians are manipulating symbols or computer programmers are manipulating symbols. And yet people are like, but their brain doesn't do that. And you're like, well, how do you know that?
Yeah, a neuroscientist friend of mine is fond of saying, if someone says neural and they're not talking about tissue, quote, they're either ignorant or lying, which I think is harsh, but, given how little we actually know about how brains work and how neurons work, perhaps not inaccurate.
Yeah, I mean, one argument you'll never see me make, although it's often made, is we don't know how backpropagation is implemented in the brain. And so some people say, therefore, there is no backpropagation. And I have my reasons for being skeptical about backpropagation, but that's not an argument that I bring out. And I don't bring it out because we don't know the mapping between almost anything cognitive and how it's represented in the brain. And so we're certainly not in a position to say, no, the brain could not do X. We can make behavioral arguments and we say, the brain doesn't look like it's doing X because, generalization Y happens or something like that.
Well, you could say, given my model of neurons, then blah, blah, blah would have to be true for backprop, and then therefore, blah, blah, blah.
You can make arguments like that, that's fine, but the level at which we understand the brain is really, it's pre-Newtonian. It's like we don't really have a theory there. We have a lot of facts. It's alchemy. We've enumerated facts. Some of those facts are going to survive when we have, the correct theory of the brain 50 or 100 or 200 years from now. It's not that we're going to toss away everything, but it's going to be put into a much more integrated framework than we have right now. And so, like, just one example, like, why are there 500 different proteins in a synapse? Nobody knows. How many different kinds of neurons are there? 1,000? Maybe. Nobody knows. Like, we're in the dark. And so you can't say, I know so well about how the brain works, that your theory about how the brain works must be wrong just because it doesn't match those, random facts that I know.
Right.
It makes no sense.
So there's another thing I've seen in arguments that may be a source of this. The wind is coming up, so if I get cut off, I have backups. So people actually conflate being symbolic with using logic and with being serial.
Yeah, that's another, like, that one should be beneath our contempt here, but it actually comes up a lot. Is like, people think that if the brain is a computer, it has to be sort of a serial stored program, device, straight like von Neumann, with no co-processors that might do symbolic stuff in parallel and so forth. I mean, I assume in this audience, everybody realizes that that's false, but the general public, that's a common thing.
I heard a Nobel Prize in biology once say, well, we know the brain can't be a computer because there is no tape.
I had a tweet about that the other day. Somebody was like, I'm not sure I can reconstruct it, but somebody was convinced that neural networks are able to approximate any function. And basically, therefore, they're the answer. I'm like, well, what happened to Turing? And I made a joke about, we should reserve papertape.ai because, by this parity of reasoning, it must be that a Turing machine is the solution to AI. I mean, you can't, maybe Turing machines have something to do with all this, but you can't make that level of argument.
Yeah. So you had these 4 ideas that had to be central in making a more robust AI.
Yeah.
For those who haven't looked at that paper, how about summarizing those for us?
So first of all, I'll say that I haven't looked at that paper since COVID became prominent. And I think very few people read the paper because it came out just before COVID did. But I think it's actually, in some ways, the best paper I've written. I hope people will eventually take a look at it. So I started by talking about generalization and symbols and why we need hybrid AI. And the basic argument there was that some forms of knowledge are expressed at a level of abstraction that neural networks just aren't very good at. Or let me be more careful, some neural networks are not very good at. And so the kind of neural network that's good at pattern classification, but not at that kind of generalization, is not going to solve this on its own, no matter how impressive some subset of the results might be. And so the first part of the argument was why I think that we need hybrid AI. And it was also a lot of references to show that it's actually happening, because there are a lot of people who behave as if there is no such thing as hybrid AI and there's no research efforts. But I pointed to 20 different recent articles that were all interesting, all chipping away at that problem. Then I talked about knowledge per se. So it's really become, and I attribute this partly to the success of DeepMind's Atari game system, a trend to not have explicit knowledge in systems. I know that you have not followed that trend. Not everybody has. And at this conference, probably most have not. But in the field as a whole, knowledge in the sense of like information you might find in Wikipedia or in the psych system, that's symbolically represented and that's widespread, at least in some domain, it's just not been part of the puzzle. So DeepMind managed to play breakout without knowing what a paddle is, without knowing what a ball is, without having a representation in XY coordinates of where the paddle is right now, all the things that a knowledge, a KR person would start with. And they say, well, you don't need it. Look, we beat a human in breakout. But what not everybody remembers is if you move the paddle a few pixels, the whole thing falls apart. So it was a completely knowledge-free, almost completely knowledge-free solution, but it was fragile. And then they pulled off the same trick again with Go. They had pretty knowledge-free, not entirely, and I wrote a paper about why it wasn't entirely, but largely knowledge-free system that solved, a pretty impressive problem. And a lot of people generalized from that to forget knowledge. That was a mistake of the 70s. Let's not do that. Let's just, throw more data at the problem. And I'm sure some people see GPT-3 as proof that you can't that you don't need to do that, but I don't. I mean, GPT-3 wasn't out, but I went through GPT-2, which had just come out, and went through all the ways in which its knowledge are pretty fragile. And I just gave you an example from GPT-3 with the cranberry juice. It's essentially of the same form. So the second part of the paper was arguing we really need to have knowledge. The third part of the paper, and I actually forget the order of these two and how I finally resolved the constraint satisfaction problem, but the other two were about reasoning and cognitive models. And I used Doug Lennett's psych system and his recent example of Romeo and Juliet to make some of these points. So he showed, and there's a real problem with it, but also something that's really deep about it, that you could get a reasoning system, psych, that had a large background knowledge and had a specification of Romeo and Juliet to make sophisticated inferences that blow away anything that anybody in deep learning is doing. And what I said is, maybe our reasoning systems, if we had the right cognitive models, might actually be sufficient now, maybe not. But I'm less sweating those to some degree, because I think it's important that we just get back to the right kind of AI, which has reasoning and knowledge systems and cognitive models. And there's a way in which, I think the field that comes closest to cognitive models right now is probably robotics. But and there's a way in which you could think of, like, I label everything in a room as a cognitive model. But the cognitive models that are mostly being used right now are very thin. And so they don't support very rich inference. And I think we need to move to systems that have richer cognitive models. The big problem with psych is those cognitive models are basically hand-wired. So what would really impress people on the symbolic end would be if the symbolic end, and I know you've done some stuff that's relevant to this, but if the symbolic side of this dispute, and again, I think hybrid is the right solution, but if people that leaned into the symbolic side could say, take video input, parse it online, and then make sophisticated inferences out of the models that they derive from the parsing online, then that I think could maybe change the tide.
So in fact, if you look at the qualitative reasoning community, I'm thinking of Tony Cohn's work in cognitive robotics. They use qualitative models as a way of going from tracker signals into qualitative descriptions, that then they build up descriptions that tie into language. So they are actually tackling the whole pipeline of getting the modalities right.
And I think that's the right way to go. I mean, I haven't followed what Tony's done in, let's say, the last 2 or 3 years, but I can imagine taking some of the general approach that he's taking, putting in deep learning to help some on the perceptual side. Like, I don't think we should toss it aside, and doing quite well. I think that the standards these days tend to be sort of broad coverage rather than the depth of analysis that you can do. And I think stuff leans into the deeper analysis. And when we can get to where you have the broad coverage and the deep analysis, we'll have made real progress.
Look, here's the problem with the state of the art in reasoning right now. So the state of the art in reasoning right now. So we have superhuman reasoners in terms of stat solvers, things that do model checking. So you put in a new code check into Facebook. It's got analysis routines that basically are doing reasoning against the 100 million line code base and sending you back feedback.
You told me there was no symbolic stuff in production at Facebook. It wasn't true. Sorry.
Right. Well, well, and as you point out, Google's knowledge graph, right? Yeah. So there's two interesting things about that. A billion node knowledge network, which Hinton always used to say you never could do. Well, oops, they're in daily use now. Bing has the same thing. And if you look at the Automatic Knowledge-Based Construction Conference, which used to be a NeurIPS workshop, now it's a freestanding conference, they are all over hybrids, right? And pick a point in the hybrid space. Someone in that community is exploring it because they want to build knowledge graphs from open media, and they want to do reasoning with them at scale. So one of the questions that someone asked in the channel before is, so what's your favorite bets in terms of hybrids these days?
I've not seen anything that completely satisfies me. I think that what we're striving for is kind of a fluidity of moving between representations. So if you think about Kahneman System 1 and System 2, that's a kind of hybrid system.
Right.
And there are problems there, some of which I wrote about in my book Kluge a number of years ago. It's not perfect, but it's pretty fluid at going back and forth. And in fact, you can do things like you can take your system 2 intention and try to recode it in system 1 so that you'll actually act on it in real time. Clumsy, but it can actually get the job done. What we need, I think, is fluidity. I think I got this following example from Artur Garces, and may not have made it up myself, but imagine that I show you pictures of horses and then say a zebra is a horse with stripes on it. So now you've got a visual database and labeled examples, just like this, canonical supervised learning thing, and you've got some verbal stuff. You want to be able to go back and forth between them so that you can now recognize a zebra from that one instruction. And humans are the cultural animal, and a lot of that culture comes from explicit transmission. I tell you that, your segmentation is not working and maybe you should wear a hat next time, and you can on one trial go see if that works any better.
Yeah, we call companions, not jokingly, the first Vygotskian cognitive architecture, right? Because we take the cultural input seriously.
Yeah, you have to be able to do it. You could argue that GPT does a form of that, but nobody's really got a system where you can just kind of fluidly go back and forth between these things. A lot of what people do is kind of bolting on for a problem, and I think there's value in that too. So sometimes it doesn't go as far as you want, but like Josh Tenenbaum's been doing some stuff lately where you have perceptual recognizers that are basically deep learning. Then you bolt on symbolic primitives and you reason from there. I don't think he's shown well that they can scale, but I think at least in limited domains, they sometimes do much better at understanding relationships than a pure deep learning system. Sure. And the deep learning helps you get off the ground on the perceptual side.
No, we've been experimenting with hybrids too, using our CogSketch system and visual analogy to do high-level processing. In some cases with normal edge finders, in other cases with deep learning image recognition systems as inputs. The trick with those things, though, is if you've got one part of the system that is totally opaque, then you can't fix it very easily, right? I mean,
that's right.
So
you can do some filtering. You can rule out things that are reasonable, but the opacity of deep learning is a problem. And one hedge that I make in the paper is I say hybrids of deep learning or things like that, and I actually give some other pointers to other kinds of probabilistic approaches and so forth. And I'm not sure deep learning will stick around despite its success, because I think that it might be beat in its own game in two ways. Someone might do it more efficiently or more transparently.
If you had something that wasn't insanely data inefficient and explainable,
then it would just wipe deep learning off the table, right?
Yeah.
And there's enough room there, enough headroom that one could do better on both. And so, the thing that in my discussions is, filling that role might turn out to be different, right? It might turn out to be closer to some Bayesian approach that's more structured, and there's still going to be something doing pattern classification. But boy, if you could do that pattern classification with less data and more transparently, that would be really, really useful.
So one way I've been thinking about it is, if you're looking at symbolic modeling and you're looking at most cognitive architectures, the big problem we have is, if you will, the modality problem, right? You need robust vision, you need sketch understanding, you need language understanding, and those things are integrated in us. And building systems, I mean, you can build reasoners till the cows come home, but if they don't actually integrate in with modalities, cognitive architecture really is where it's at in terms of building these things out, I would think.
Yeah, I mean, the term I use, by the way, is cognitive models. I don't know if you were alluding back to that, but so like your sketch understanding system, part of what it's trying to do is to build a cognitive model of the sketch that it's to understand.
Yeah.
And I think that that's essential. I think, if we've learned nothing from the last few years, it's that you can fake it pretty well in some context, but also that faking it has its limits. So you gave the example now of the calendar entry. Like you could fake it on word usage and be right 9 times out of 10 and then miss a vital meeting. Or people fake it, in like NVIDIA had this end-to-end driverless car system, deep learning driverless car system, and it seemed to work well, but then you read the fine print, this is the first end-to-end driverless car thing. It needed an intervention every 600 hours, which may not sound like much, but if you know how good actual humans are, that's really actually lousy. And
In
you
fact,
couldn't do it in the real world.
that's pessimally bad from a human automation standpoint, right? Because it means people will lose the bubble and not track.
Right.
And then when
Yeah,
things go
exactly.
wrong,
Yeah, it would be criminal to put that in the road and say, I've got an autopilot here. I mean,
yeah. So,
maybe Tesla does, but it's better than that.
so speaking of robust AI systems, you've got a startup called Robust AI.
I do, not coincidentally, yes.
Tell us more about that if you can, whatever you can tell us.
The goal is to make robots smarter, to make a platform to make it easier to make smart robots. So you can think about game engines. With a game engine, like anybody could go write their own physics and collision detection and so forth, but they have a creative vision that they want to explore. So that, they kind of game that they have in mind. They don't want to write all that stuff. We want to make it so that if you have some fun thing you want to do with your robot, you don't have to figure out everything about common sense and how the world works and physical reasoning and psychological reasoning and also some low-level infrastructure stuff. You can just use our tools to get your robot to do what it wants, whether that's in construction or your domestic robot or elder care robot or delivering packages to somebody's door as opposed to the sidewalk. We want to build the set of tools that's going to get the robots to be robust enough that you can actually trust them.
Yeah, Rod Brooks couldn't resist telling me in February that he's building a symbolic planning system.
Yeah, isn't that amazing? I got Rod doing a little bit of symbol stuff. I mean, Rod's doing multiple things for the company, but he is actually, embraced what he would think is the dark side because he's a pragmatist. More than anything else, Rod is a pragmatist, and so he's known for all of this kind of, representation-free stuff that he argued for as a youth. I sometimes joke about the early Brooks and the later Brooks. So the later Brooks is a pragmatist who wants to get stuff done and who sees that different aspects of the problem need different solutions. You need different tools for different things.
No, I thought the acronym system, vision system he did, was a real landmark for its time. And using generalized cylinders and ribbons later on, he did a lot of great work there.
He's had pragmatic moments all along.
Yeah.
But I mean, he had his most strident moments relatively early in his career, and I don't agree with everything that he said in those strident moments. I think we often think of in the company like, is there a really crude way of getting 96%, and would 96% be good enough here? Or do we need a deeper solution?
Yeah.
We at the company we take everything to be an empirical question. We despite, I guess he and I are probably both known as being dogmatic, but in our own ways. But at the end of the day, in the company, we're trying to make something that works for a large number of people, and so we're like, what is the compromise that's going to make sense empirically in this particular aspect?
So how do you do something that broad without basically replicating the Psych project?
Well, I guess there's a few different things. I mean, I don't think there's any risk of us replicating the Psych project, although there's a risk that we might need to do that as a subcomponent. But I hope not. The Psych project, by and large, right now, as I understand it, is a knowledge base and a reasoner, but it does not build world models, and it doesn't reason over those world models.
It's not quite right. I mean, it does. They have application contexts where they are building up models of particular humans and building relationships with them.
Sure, but they're sort of like hand spun and they're limited. So there's nothing there. I mean, there's no vision system. There's no real parsing system.
There are language systems, and I use the plural advisedly.
I've gotten a demo of a language input system. I've seen a lot of natural language generation from it, but like take an example, the Romeo and Juliet thing. So there's no way right now that you can feed in either Romeo and Juliet or even the Cliff's Notes version, have it derive the model from there.
Oh no, that's quite hard. But given the applications they're doing, that's actually not a necessity.
Yeah, I mean, look,
they pick their shots carefully, right?
They have some, they have picked carefully what problems they can work on relative to the strengths and weaknesses of the system. I think that the reason they haven't taken the AI field by storm, even though I think there's value in what they've done, and maybe great value in what they've done, is because they don't have that front end to derive the models from arbitrary things in the way that, arguably deep learning has done well, not perfectly, but like if I just want to segment a generic scene, I can throw deep learning. Well, it's not working all that well on
Right.
you today. You know, the that
I
kind of
always get,
tool
I
where
always
I
get,
can just put something, put this very cool middleware into kind of easy to use packages doesn't really exist for it. And I
yeah.
think that's slowed commercial adoption. We're trying to make systems, they're more end-to-end than that from the user's perspective, and that leads us in a different direction. So we need to do some of the common sense stuff. We maybe don't want to take on the full range, or at least not anytime soon. But we need to make things that have their own perceptual systems and action systems, derive the models in between and reason over them.
So there's a world where you deal with, I'm manipulating an object here, right?
Mm-hmm.
There's the world where I'm telling you socially what the implications are of doing this, and something that solved the first but didn't solve the second would still be of an enormous value commercially.
Yeah.
So that seems like the obvious place to start, right? Because that's where you've got the most leverage.
Well, we don't necessarily want to start with manual dexterity because
the bots can't do that, right? But the physical manipulation and
physical understanding of the world, is let's say we already started some on that, and that's high on the agenda. Whereas physical manipulation is a little bit later. And I mean, look, in the end, I'd like to boil the ocean, but we can't boil the ocean all at once. So the best that we can do is to pick some sub problems that are
right.
more manageable and try to get enough traction on those that we have more leverage to try even bigger problems over time.
So what's interesting is, if you look at robotics, that puts you into a particular subset of common sense problems. If you look at an analysis assistant, where you're doing business analysis or helping a scientist or an engineer, you're doing different kinds of physical stuff, right? You're never actually grabbing anything or worrying about manipulating it. Yeah. But you are thinking a lot more deeply about how the physical phenomena works in some cases, or you're worried about the social effects of something that you've seen in a video. Yeah. And so in some ways, there's a small set of application areas which collectively would actually span human common sense. And if we're clever, we can actually find ways that people will pay to have this done. I mean, that's been the big problem, right? So the billion fact knowledge graphs from Google and Bing do not have a lot of common sense knowledge because that's not immediately useful for them.
Yeah, I mean, there are lots of commercial problems where it turns out you can sidestep common sense at all. Part of why I was attracted to robotics is because it's a problem where I think the rubber meets the road and you really need a deeper representation in order to solve the problem. And I figured if most of the people were going to try to solve it without, they weren't going to succeed. And that left room for those of us who are willing to confront those problems to do something interesting and novel.
Yeah. So in terms of the state of the art of today's AI, Ferrucci, right, of Watson fame, with his new startup Elemental Cognition, has a similar critique.
Parts what you just said. Richie?
Dave Ferrucci.
Oh, Ferrucci, Dave Ferrucci,
yeah. Elemental Cognition.
Yeah.
Similar critique, right? He calls transformers super parrots.
Yeah.
And yeah. So what do you think about the approach they're taking at Elemental?
I don't know it in detail. I know only the vaguest things about what they're really trying to do commercially, and have the sense that they're pretty patient and working more on basic research, which I think is fine since he's able to bankroll that. I think that he's got a good sense of what the real problems are and a clear sense of, say, why Watson, which he built, is inadequate and what actually needs to be solved. So I don't know enough about the particulars of what he's doing to say that he's solving them or not solving them. But I like his overall perspective on the field. I think he is not easily fooled by the super parrots, and is in a position to do something interesting. I look forward to hearing more when he's ready to unveil.
Yeah. So let's start looking at the Slack for questions. So let's see. From Clink, many people who built systems off Psych or existing semantic web ontologies. Have people looked at using GPT in place of those ontologies and then building the symbolic system off of that?
I mean, my answer would be, I hope not. So GPT probably has more coverage than Psych, even though Psych has been around a lot longer. So that it can probably talk about some things that just don't happen to be there. But the knowledge that's in Psych, as far as I can tell, generally tends to be correct, whereas the knowledge that's in GPT is hard to directly extract and it's not very reliable. And so it doesn't seem to me like a win there to do that.
Yeah, so to channel someone at the AKBC conference who was using deep learning techniques to construct knowledge graphs for medical reasoning, his point was, I can't use a language model as a knowledge base because they, quote, they make shit up.
Yeah,
and so if you've got a medical...
You pour your grape juice in it, you sniff it, can't smell anything because you have a cold, you're thirsty, you drink it, now you're dead, right? That's not a good model of medicine, that you will die if there's grape juice inside your cranberry juice. And you don't want to count on that.
No, I do know people who have tried to various degrees of success to say, given facts about, say, or relative sizes of things that are stated in language, can use that to pull those out as an oracle for particular things. But again, it's got that.
A grad student, the hot thing was LSA, which I'm sure you remember in some of our audience.
Oh, yeah.
And the demonstration that wowed some people was the demonstration that disgusted me. And it was to reconstruct the map of the United States based on basically correlational data from corpora. And you can figure out some things from that. Like you can figure out that New York is closer to Boston than it is to Montana. But you also have confusions. Like you start thinking New York and Los Angeles are close together because they're correlated. And GPT-3 is just, that taken to an infinite power. It has, it's even better. You could make an even better map trying to pull that stuff out, but you can never count on it because there are always things that correlate with the language model other than the things that you care about.
Yeah.
You want to know about size better, that you should have a ruler than that you should do it that way.
Yeah. So question from Johan de Cleer, who says, well, what does Gary think about Rich Sutton's essay, The Bitter Lesson?
I'm bitter. I talk about it in the paper. Look, I think, to the world's perspective, Rich has the upper hand right now, right? His view is the thing that has worked better is having more data. But history can change, right? If you looked at 2009, you would have said neural networks are a failure. They can't work. And it turns out that they just needed another ingredient, and then they worked very well. And that ingredient was GPUs, or GPUs plus big data. And so the kind of argument that something can't work, you have to be careful about is part of it. And part of it is most of the things that have worked with the kind of bitter lesson have been fragile in the ways that I'm talking about. And so they're okay for some things. Like Google Photos is a tremendous application of bitter lesson style architectures, right? I mean, you don't really need to know that much about the world to do very good photo tagging. And it doesn't have to be perfect. Nobody's going to sue Google if their, Chihuahua gets mislabeled as a cat once in a while.
Although if you label people as gorillas, they do get testy.
That is the problem. There's a whole other line of issues there. But, you can find applications. Some of them have problems. I don't want to disagree with that at all. And they can be pretty serious. But you can find applications for these things. Speech recognition is another one. And there are bias problems there too. I mean, so they're not perfect. But you can certainly make money if that's your criteria. And it's only, in my view, one criterion in life. But you can certainly make money using these tools that are not, at some level, trustworthy. But you get into these bias problems precisely because they're not trustworthy. They're just data mungers. So if you took one of these systems and did job recommendation with it in 1910, you would say there is no way that a woman can be a classical musician. It's never happened. And so I predict every woman that you put in, chance of her becoming a symphony musician is zero. And what you'll be doing is perpetuating a historical bias rather
Right.
than, because that's what these systems do. They perpetuate, historical biases.
Cultural fit. Right.
Cultural fit is be a polite way to put it. And so, that's where the bitter lesson gets you, is systems that don't understand the data that they're working in. And so they can't break out the level of abstraction that we would expect of a philosopher, or hopefully just of a decent human being. They don't have the wherewithal to do that. Nor do they have the wherewithal to, say, calculate harm, right? When you think about Asimov's laws and you want to have a robot compute harm, these systems can't do that.
So part of the problem with the public perception is they don't know about things like Google's knowledge graph. They don't know about superhuman reasoning systems. And so the impression is, well, the only things that work are the neural nets.
Yeah,
I've had people tell me this.
The media has done a terrible job of educating the public about the subtleties. There are a few good people, I like James Vincent's pieces are often careful and analytic. But by and large, the media has, taken everything that Hinton has said and glorified it. And another example is Hinton said in 2015 or 16 that, we might as well stop training radiologists. And people did, because there were all these articles about how we should stop training radiologists because deep learning was taking over. Well, now we have 400 deep learning startups. No actual radiologist has been replaced, but you don't see 100 articles saying, hey, maybe Hinton was wrong and we were suffering. The media doesn't do that.
In fact, a colleague of mine was talking to radiologists at Northwestern, and they first started saying, well, can we have something that helps us do the labeling? And he said, well, when you're looking at one of these pictures, do you ever talk about it? I say, well, of course, we talk about it all the time. It's like, wouldn't you like a system that could talk about it too? And it's like, oh, of course we do. Of course we do.
Product fit side of things too, that has gone awry with the radiology thing. One example was, not radiology, but a similar thing was, people said, oh, wow, we could have a cell phone tell a dermatologist whether they need to do a biopsy. And the dermatologists are like, I already know that. That's not the hard part. There's often a misfit. And, that's a problem, I think, anytime people try to take research into the real world, is you have to understand the customer problems and so forth. But the problem that I was dwelling on there is that the public has been, by and large, misinformed, because the narrative of the media is triumph, especially in science. It's not the narrative in politics. But in science, they always want to say, this great new discovery will do this. And so if you go back to deep learning in 2012 and all the things that were written about it, the only one that was critical was my piece in the New Yorker in December 2012. It was literally, I think, the only critical piece. And there started to be this tsunami of deep learning positive stuff. And you would have projected that you'd have driverless cars by 2017. And in fact, Sergey Brin got up on stage and said that, and it didn't happen. And you would have projected that we would have chatbots by 2019, and it didn't happen. But the media doesn't very often come back and say, hey, all that stuff we told you about how imminent AI was with the deep learning stuff, it's wrong. Instead, they run another piece about how cool GPT-3 is, and they don't even call me for comments. And if anybody's going to give the critical comment, tell me. If it were politics, they'd never do the same thing, right? They would know we should at least ask somebody else. And, that just doesn't happen.
Yeah. I remember Rod Brooks' response to Elon Musk's prediction about 1 million self-driving cars in the street, which was, if he does that, I will eat them.
Still hasn't happened. I mean, Elon has been issuing empty promises for 10 years in that field or something like that. He's very rarely called to account. People just it's like that scene in Airplane. You remember when in the original, when they're landing, they say, now arriving gate 1, gate 2, and the plane can't stop. Now arriving gate 8, now arriving gate 9, now arriving gate 19. Well, now arriving this year, driverless cars. And now we're moving into, quote, feature complete driverless cars, which means nothing. They've been feature complete for years and years. Feature complete means I can type in A and B and it might get there and it might not.
I was at a policy meeting where there were a bunch of education ministers from various European countries, and I spent a good half of my time debunking journalist myths about where AI was.
Yeah, again, they're not all, letting the charge down. And again, Vincent's probably my favorite, James Vincent, through Harwell is the pieces. But the bulk of what you see really tends to be on the glorification side rather than the careful consideration. And that has an effect over time.
Yeah. So let's see, other questions here. So one person, Ed Harvey says, I want to hear more about next steps, how we move forward, finding something better, more robust.
I mean, I would say that, the Next Decade article, which I hope you'll go read, is trying to be at least a little concrete about what those steps ought to achieve, but I don't think anybody knows how to achieve them. I think we're something like in pre-Newtonian physics or chemistry before people figured out the periodic table. We just don't have a fully integrated theory. I think we have strands of it, but I don't think anybody really knows exactly how to do it. The reason I write the pieces that I do is to try to refocus people's research efforts. So I've seen at a few times in my career, people get really excited about the next big thing. And the next big thing to me doesn't look profitable and usually turns out not to be, but often costs a lot of money. So the other example I saw was cognitive neuroscience, completely swept aside cognitive psychology. All the smart people started going into brain imaging. And I think, in 1997, everybody thought that was great, and I thought it was terrible. I thought it was a waste of tremendous talent. And now, most people realize that that literature has not been convincing. There are a lot of problems with it, a lot of replicability issues, and that it was at the wrong grain size to really give us the right answer. One voxel in a brain image is 70,000 pixels. It just does, 70,000 neurons. And 70,000 neurons is just too far away from the action. So neuroscience may make some progress yet, but that whole field sucked up like 85% of the cognitive science funding over a period of 20 years. And I think it was a tragedy. Right now, I see machine learning that way. Not that I'm anti-machine learning. I think machine learning is definitely part of the answer. But I think that the emphasis is on learning stuff bottom up without knowledge, without cognitive models and so forth. And that piece of machine learning is limited in its application to these cases where you don't really need to count on the answer. So I'm trying to reshape people towards how do you bring back knowledge into the picture? How do you have some innate knowledge, some learned knowledge in a context where you still acquire stuff? But think about Nell, right? Nell's trying to learn everything almost entirely bottom up. It's been running for, a decade or longer. There's no profound knowledge that has been acquired by Nell. So does that mean that we abandon the project of trying to learn from the internet? No, absolutely not. But it means we need to rethink it. And I'm trying to just point to direction. It's like everybody's looking to the left. I think we need to be looking more to the right. I don't know exactly where should look.
Well, amusingly, you're talking to perhaps the highest density of people on the planet
who are
thinking in terms of systems that know stuff.
Yeah. I'm glad to be here, and I'm glad that there is some density. I would like to see people of this community better funded, taken more seriously. I think that resources have gone too much in the other direction, and I know these things are pendulum, and I fully expect they'll swing back. They may even swing back too far. It's possible, but right now they're too far to one extreme, and so you have a lot of people kind of working on problems like how can I learn ImageNet faster, and I don't think that that's helping us. I think we need to be more like, how would I take ImageNet and combine it with all of the world's knowledge about animals that is represented in WordNet and Wikipedia and come up with something that takes me to a new level.
Yeah. Okay, let's see. Any more questions from people? So here's a question more about the startup. Have you run into problems of contextual sensitivity in interpreting orders? And is that rolled into what you mean by common sense?
I'll be a little bit coy. One might imagine that would be something we would take very seriously.
Yeah. Feed the cat. To whom?
I mean, if we're going to succeed in our mission, we need to have a pretty good answer to that set of things. You need to know enough background knowledge about people to understand what they're asking. You have to be able to have a parse that's rich enough relative to the world as it is in this particular moment. You can't just sort of do the Alexa thing of pretty much ignoring the context and just having like frozen answers. So when you ask Alexa, tell me a joke, Alexa doesn't read the room, it just reads from a list. But our system has to be able to understand, you know, the scenarios and the stuff that you wouldn't say, but that is important to you. So, you know, we're always hiring, and that would be an area that would be of interest to us.
Yeah. So Sean Kugel from Memphis asks, what are good benchmarks for evaluating hybrid systems? So are there benchmarks that balance perceptual tasks and reasoning tasks, or are all the existing benchmarks inadequate?
I don't think there's anything there that I'm satisfied with. There's been a lot of proposals in the last few months that I can't swear I've read them all. One thing I've been pushing for a long time is basically a comprehension challenge. I think I've first publicly said that in 2015, maybe.
A real comprehension challenge, though, right? No multiple choice.
Not multiple choice, but open-ended. So you should be, the example I gave then, because Breaking Bad was hot, was something like, you know, why did Walter, you watch Breaking Bad, all whatever, 70 episodes. Now I say, why does Walter White want to take a hit out on Jesse? And you should be able to put together what you've viewed and have an understanding of people's motivations and why they would do things, and be able to sort of answer arbitrary questions. And then with Praveen Paratosh, who is or was at Google, I wrote a piece in a special issue of AI magazine that was about what we called, what some of the other set of us called the Turing Olympics. Praveen and I wrote a piece about how you would crowdsource the questions and answers for an open-ended comprehension challenge, which is still, I think, something that's hard but could be done if the spirit was willing. And I think, you know, one positive sign of AI, let's say pre-COVID, but in recent times, has been more open-mindedness to broader sets of benchmarks. I think there's been a collective sense of frustration that, like, okay, we've solved the Winograd schemas, maybe depending on your criteria, but we're still not there, and we haven't really made that much progress. Like, people are really realizing how much these things just inevitably get gamed, and there's a lot of hunger for something more. I don't know if any one test can be adequate. You have to remember that intelligence is a multidimensional variable. We promised we'd talk about analogy. We never quite got there, but you know, analogy, for example, is a different kind of intelligence than the brute force that you need to search chess positions. And I don't know that any one test is going to get at all of those kinds of things. And there are forms of intelligence where machines already, you know, kick humans behind. So you know, doing arithmetic, there's no point in having a benchmark. It's just so obvious that they're so much better. But on comprehension, it's so obvious that people are so much better that it's almost not worth running the test.
Yeah. Let's see what we got here. Oh boy, XAI, giving explanations, a lot of conversations. So hopefully, if you check it on the Slack channel, you'll find it to be fun.
I will, if I can, I'll join the Slack channel. I guess we're winding down, and I can stay for like 20 minutes for more questions over there.
Yeah. So let's see. Any last questions, people on Slack? I'm looking. I'm seeing great discussions, but everyone's answering each other's questions. So
it's like a dinner party where everybody's talking at once, talking together, and then they break up.
Yeah.
All right. Well, why don't we can leave it there, and then we can.
Okay.
So we can end this session, and then we'll start the poster session now. So we'll sequence those talks here in the chat. If Gary could look at the chat, the
where should we go is my final question. Which chat room channel or